Hello viewers, Wagadar taking you through the story for A-Level Physics Paper 1. And this video we're going to go through the topic of vectors and scalars. So this video is suitable for students in both Senior 5 and Senior 6 offering physics as part of their combination. So before we proceed, let's first look at the course outline of this paper. So physics paper 1 is divided into 3 parts. The first part is mechanics, where 4 questions come from these topics. The second part is heat, where 3 questions come from these topics. And the third part is modern physics, where 3 questions come from these topics. So what is ticked is available on this platform, and what is not yet ticked means we have not yet uploaded. And this video we are going to go through the topic of vectors and scalars. So on this platform, you're interested in the calculation part of it, but complete notes are available in the book called Mastering A-Level Physics Paper 1. So it contains clear notes, worked examples, and trial questions on all the parts of Physics 1. So if you need a copy, contact the author on any of these 2 contacts. Remember, physics, a question consists of definitions, explanations, descriptions, and derivations, and also calculations. But on this platform, you only answer one part, which is the calculations, to the full. So that means that the rest of the parts, you need to buy the book for you to also be conversant with them. And a complete set of physics has 3 books. There is Physics 1, then there is also Physics 2, and there is also a topical question bank. So with these 3 books, then you are good to go. The same applies to Principal Math. Principal Math, there is Math 1, Math 2, and a topical question bank. For Subsidiary Math, it is only 1 book. So for any of the copies, contact the author on any of these 2 contacts. So now we shall start our topic of vectors and scalars. So because we are in Senior 5, we shall link this topic with what you already know. So when you enter A-Level, don't think that everything will be so different from what you covered in your O-Level. So in O-Level, you covered some bits of vectors and scalars. So that's where I shall begin from and shall keep on building on what we intended to learn in A-Level. So scalar quantities and vector quantities, these words are not new. So a scalar quantity is a physical quantity which has only magnitude. Now in A-Level, we are strict on the definitions. For example, in O-Level, you could say a scalar quantity is a quantity which has only magnitude, and it would be okay. But now we are interested in seeing this word physical quantity. Now examples of scalar quantities can include work, power, speed, distance, temperature, area, volume, charge, kinetic energy, pressure, and so on. Then on the other hand, a vector quantity is a physical. So this word physical is now needed in A-Level. Is a physical quantity which has both magnitude and direction. And examples can be displacement, velocity, acceleration, force, electric field, momentum, and so on. So that is the difference between scalar quantities and vector quantities. Scalar, we are only interested in the magnitude, while vector, we are interested in also the direction. Okay, now we shall go to what we call sign convention of vectors. So in this, vectors in opposite directions are distinguished by a change of sign. So yeah, this should have been changed by a change of sign. That means that if one is positive, the other will be negative. And in this sign convention, we dictate what should be negative and what should be positive. And the easiest way of remembering it is by using this plus sign, whereby horizontally forces to the right or vectors to the right will be positive and vectors to the left will be negative. That is horizontally. Then vertically, vectors upward will be positive and vectors downward will be negative. We shall see all this in the worked examples, but we're trying to build on. So here, like I've already told you, the notes we give are brief and shallow because they only help us to understand the calculations. So don't be tempted to think that the notes I give here are the complete notes. The complete notes are available in the books I've encouraged you to buy. So that was sign convention. Then another part, we need to know what we call magnitude and direction of a vector. So still you have some idea, but shall just build on what you know. So once a vector has been written down, it is easier to extract from it the magnitude and direction. So if a vector is in 2 dimensions, we need to complete the triangle and apply Pythagoras theorem to find the magnitude. So how do we do that? We shall say what is done. So that then direction, here in A-level, direction means angle. So direction is also obtained from the same triangle using trigonometry. I think you remember SOHCAHTOA in O-level, which was used for right angle triangles. So we shall also be using it here. So in vector form, the magnitude of a vector is denoted by these 2 vertical lines, and they should be straight. Now, they should be straight. Some students are funny. They may put a box bracket. That is never okay. Magnitude, it has to be just vertical straight lines. For example, here, this means magnitude of vector R. So in vector form, I think you remember a vector can be written in column form in this form, x, y, where x is the horizontal part or the part on the value on the x-axis. Then y is the value on the y-axis. So x is horizontal, y is vertical. We shall see how that one is helpful. So for you to get the magnitude, just get this squared plus this squared and everything under a square root. That is how we get the magnitude of a vector. Then the angle or the direction will be got by using tan theta, where theta is the angle or the direction. Remember we said in A-level, direction means angle. So tan theta will be equal to y over x. Note the order. The one down should be the numerator and the one up should be the denominator. So don't interchange. If you interchange and you say tan theta is equal to x over y, it is never okay, as we shall see in the examples. So the direction of a vector can be stated in any of the 3 ways. So in A-level, they'll tell you to get magnitude and direction of a vector. Now the question is, how do you state the direction? So direction can be stated in 3 ways. So one can be in terms of the angle it makes with the horizontal or x-axis. You can say 30 degrees above the horizontal or 30 degrees below the horizontal. Or you can say 30 degrees above the x-axis or 30 degrees below the x-axis. That is one way you give the angle basing on the horizontal or basing on the x-axis. But we shall see all this. Then another way can be in terms of bearing. So bearing, in your O-level math, you did much of the bearing. So that is also another way. What you should remember is that for bearing, angles are measured starting from the north direction going in a clockwise direction. Okay. Then another way can be in terms of compass direction. Compass direction, you're also aware of it. For example, when I say north 30 degrees east, that is a direction in form of a compass direction. So these are the three ways you can use to state the direction of a vector. And shall see all the three, how you can state all the three ways in the examples. But for you to easily memorize them, especially the first one, we shall need a diagram. So let's illustrate with a diagram. These ones are okay because we did them in O-level, but this one is a little new, so we shall expand on it. Let us consider these four angles. I think you realize all of them are lying on the horizontal. Okay. So how can we state this angle theta 1? Theta 1, we shall say, is an angle above the positive horizontal. Now, where does that word come from? Like you know, a number line, values here are positive. Values this side are positive, and values this side are negative. Okay. Then, if this is the horizontal, then here it is above, and here it is below. Good. Now, when you say theta 1, it is on the right side, which is the positive side, as you saw here. That is why we use the word positive. Okay. Then also it is above this horizontal line we drew. That is why we use the word above. What will happen to theta 2? Theta 2 is on the negative side. Therefore, it will be, but it's still above the horizontal, so we shall say above the negative horizontal. What about theta 3? Theta 3, it is below the horizontal and also on the negative side, so we shall say below the negative horizontal. And lastly, theta 4, it is below the horizontal and on the positive side, so we shall say below the positive horizontal. So that is how you can state the end of these angles in case you come across them in a question. Then these ones of bearings, it is okay, you are constant with them, but you shall still see how you can state them in the examples. So let's do some simple question here. It says, find the magnitude and direction of each of the following vectors. So this is vector 1, ij. In column form, it can be written as 3, 4. I think you remember that. Then this is 6, negative 8, negative 4, 3, and negative 8, 6. So the first thing to do is to illustrate. So you shall let R be the vector here. Then you illustrate. Now illustrating, I think you remember the sign convention. Sign convention says this horizontally forces vectors to the right are positive and to the left are negative. So when you see this one, it is positive, therefore it will go to the right, like that. Then this one is also positive, meaning it will be up. So vertically, upward is positive, so it will go up, like that. Then the resultant is the line joining from the starting point to the end point, and the arrow matters. The arrow must point from start to end. Therefore, we shall come and join those 2 points with a straight line and call it our resultant. So this is vector 3i plus 4j. Therefore, the magnitude, I will say this squared Pythagoras theory plus this squared, everything under square root, to come up with this as the magnitude of this vector. But they also ask for the direction. Now, direction, first of all, we shall use SOHCAHTOA to get that angle. So SOHCAHTOA, this is opposite, this is adjacent. Therefore, we shall use tan. Tan is equal to opposite over adjacent. Therefore, theta is equal to this. So angles are rounded off to 2 decimal places. Then now stating, we have got the magnitude, we have got the angle, now we have to state the direction. First of all, this angle is above the horizontal and on the positive side. So that's why you say above the positive horizontal. Then part B, they wanted you to get the magnitude and direction of that vector. Still shall do the same procedure. This I, or horizontal, is positive, so it is to the right. But vertical is negative. I think you see this -8, so it will be downward. Then you join a line from start to end. So that triangle, you can get the magnitude using Pythagoras theory and the angle using SOHCAHTOA. So tan theta is equal to opposite over adjacent to give you this as the answer. Then you can state the direction, the magnitude and the direction. So this conclusion is vital. It has to be seen. Part C, we have a negative horizontal and a positive vertical. So we shall come and draw a right angle triangle. Horizontal is negative, so put this, it goes to the left. Vertical is positive, so it goes upward. Then you join from start to end to get your resultant. Out of that, you can use Pythagoras theory to come up with the magnitude and SOHCAHTOA to come up with the angle. Then you can conclude. So I believe by now you are understanding how to get the magnitude and direction, and also how to make a conclusion. This is called a conclusion, and it is very vital in a level. So let's do one more. Part D, it was negative horizontal, negative vertical. So negative horizontal is to the left, and negative vertical is downwards. Then join from start to end, and that will be the right angle triangle we are interested in. So we shall use Pythagoras theory to get the magnitude and SOHCAHTOA to get the angle. Then we can conclude. So in this question, what I wanted you to understand is how to get the magnitude of a single vector and also the direction of a single vector. And I believe I've achieved my objective. So you can go to the next part. Next will be resolving a vector. Now resolving is now a new term to you, but we shall see what it means. So we shall start by saying this, that in the above example, we found the magnitude and direction of a vector. So we are given a horizontal part and a vertical part, and we get the magnitude and direction. But what if we want the reverse? For example, what if we are given the magnitude and direction, and they want us to get the horizontal part and the vertical part? Now you have used the word part, but in physics we call it component. So be saying the word component, it means a part. Okay, so that process is what we call resolving. In other words, splitting a vector into two components, the horizontal component and the vertical component. So consider a vector r and direction theta as shown below. So there's a vector r in the direction theta above the positive horizontal. So this vector can be expressed in the form xy or xi plus yj by resolving it into horizontal and vertical components. So this is our horizontal and this is our vertical, as follows. So one shall say, to get this one, I want to split into two, horizontal and vertical. So horizontal, it will be to the right, and when it reaches here, I can't go down. The only option is to go up. So when I reach there, the vertical component will be upward. So now the question is, how can I get the value of x and the value of y in terms of theta and r? With that, you need to remember SOHCAHTOA. SOHCAHTOA means sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. So if I want to get cos, it will be adjacent over hypotenuse, which is x over y. If I want to get sine, it is opposite over hypotenuse, which is y over r. Therefore, I want to make x the subject and y the subject. So here I'll make x the subject to come up with this by taking this on this side. And here I'll make y the subject by taking this on this side to come up with this. That means that I can now express r in the form xy by saying r will be now, this vector r will be r cos theta and r sin theta. Now I want you to master the order. The upper part has cos, the downer part has sine. Like I said, if you by mistake you interchange the two, it is never okay. So always the upper part must have cos and the lower part must have sine, on condition that the angle is to the horizontal. Okay. So whenever you are resolving a vector, the sign convention must be put into consideration. So here both were positive because this is to the right, which is positive, and this is upward, which is positive. But in case it was one of them was, for example, this x was to the left, it would be negative, as we shall see in the second example. So the second example says, express in the form this the following vectors. Part A, they want a vector with magnitude this and acts in the direction that. Then part B, a vector with magnitude this and acts in the direction this. Part C, a vector with magnitude this and acts in the direction this. And part D. So just now start with part A. Part A, they said magnitude is 250 and the direction is north 30 degrees east. North going this side 30 degrees. So this will be where the 30 will be. Therefore, you come and sketch it. So that is here, and the balanced, the remaining one to make 90 will be 60. We are putting this because we must get an angle to the horizontal. Then to come to split, we shall have horizontal to be to the right, vertical will be upward. Now here we are putting 250 cos 60 because I think remember when we were driving, this was x, this was y. And we saw at the end that x is r cos theta. Now in this diagram, r is this and theta is this. That is why we are getting 250 cos 60. On the other hand, y was r sin theta. R is 250 and theta is 60. That is why we are getting 250 sin 60. Therefore, now I can write in vector form by saying this, starting with this, followed by this. When I use a calculator, this gives me that, and this gives me that. So that is part A, this vector in ij form. So what I've done is called resolving a vector, because resolving means splitting a vector into two perpendicular components. So now this one is expressed in a column form, but the question wanted ij form. Therefore, we shall come and conclude and say r is 125i plus 125 root 3j. That was part A. Part B, they've given us magnitude of 200 and direction of north 45 degrees west. So north 45 degrees west, meaning 45 is here. So shall come and make a sketch. So is our 45 and the remaining part to make 90 is 45, that's why you put it here. We put this 45 because our angle must lie on the horizontal. Always remember that. So splitting this one gives you horizontally to be to the left and vertically to be upward. So we shall come and put to the left, and horizontally it is cos and vertically it is sine. So 200 sine 45, 200 cos 45. Therefore, in vector form, it will be now here Do you see this? By its convention, we said horizontally forces going this side are negative. That is why you see a negative here, because this one is moving to the left. Vertically upward is positive. That is why you see a positive sign here. So simplifying gives you this. After that, we shall write it in ij form to give you that as the answer. Then part C, so what I'm doing is called resolving a vector. And once you know how to resolve a vector, then the next part will be now easier for you. So what about part C? Part C still we are given magnitude and direction. So this is 60, remaining part will be in 30 to make the 90 degrees. So this time horizontally will be to the left, vertically will be downward. So let's complete that. So horizontally it is cos, vertically it is sine. Therefore I can come and write it in vector form. Now vector form, from our sign convention, horizontally it is to the left, which is negative, and vertically it is downward, which is also negative. That's why you see negative horizontal, negative vertical. So in ij form it will be like that. That was part C. Then part D, still we shall make a sketch. So splitting this, horizontally it will be to the right, vertically it will be downward. So we shall come and complete that to the right, which is positive, downward, which will be negative. So now expressing it in vector form, the positive horizontal will be positive, but vertical will be negative because it is downward. That's why you see positive horizontal, negative vertical. So now here, when we use a calculator, we shall get the value, but the value must be to 4 decimal places. Then you can write in ij form, and that's what they wanted. So what you have learned is called resolving a vector. Now we shall go to the main aim of this topic, and that is called resultant of a given set of vectors. So a resultant vector is a single vector that has the same effect as is equivalent to the given set of vectors. So it has the same effect as a given system of vectors. And it involves getting the magnitude and direction of a single vector. Remember, that has the same effect as a given set of vectors. So you can be given a number of vectors. So when they tell you to get the resultant, it means that you get one vector which will have the same effect as the given set of vectors. So now that we know how to get the magnitude and direction of a vector and also how to resolve a vector, we can use that knowledge to go through some of the questions in the U.A.C.E question bank. So question 1 came from U.A.C.E 2008, paper 1, question 1b, and it says 3 forces, these ones, act at point O as shown in the figure above. Find the resultant force. Remember, force is a vector quantity, meaning it has magnitude and direction. So resolving will give us that. Remember, resultant is a single force which has the same effect as the given set of forces. So what we need to do is to add up all these vector forces to come up with a resultant force, or to come up with the component of a single force. So how do they come about? When you see this diagram, which was given in the question, for example, this one, horizontal it is to the right and vertical it is upward. So both will be positive. So positive 3.5 cos 30 degrees and positive 3.5 sin 30 degrees. So always the one up with the upper part or the upper component will have cos and the downer component will have sin, provided the angle used is on the horizontal. Okay, then this one too is entirely vertical. There is no horizontal part. That is why the horizontal is 0 and the whole of it is vertical, which is 2. Then this 4 horizontal will be this side and vertical will be downward. Therefore, negative, negative. That's why it's negative 4 cos 60 and negative 4 sin 60. Now, when I add all these ones, the upper components, I'll come up with 1.0311. And add all the lower components, come up with 0.2859. Okay, now I've got the component. Now I've got the vector of the resultant force, but I need to get the magnitude and direction. So I'll come and draw a right angle triangle. So right angle triangle, horizontally it is positive. Then vertically it is also positive, so it will be upward. Then a line joining from start to end will be the resultant force. Therefore, now the magnitude can be got. So magnitude is that, using Pythagoras, and also the direction using SOHCAHTOA. Tan will be opposite over adjacent to give you theta as 15.50 degrees. Then you can state or conclude the magnitude is this, in the direction this, above the positive horizontal. So I think you realize that we have combined all what we have been covering. We have combined resolving a vector, then we have combined getting the magnitude and also direction, and also stating the direction. So that we can go through other questions. So question 2 will come from U.A.C.E of November 1998, paper 1, question 1c, and says, force says these ones act on a particle O as shown in the figure. Find the resultant force on the particle. So those are the forces. So you'll come and first resolve. So resolving, we shall still follow the same procedure. The first thing to do is to get the angle to the horizontal. So come and get this angle, it will be 45. Okay, now I can resolve. For 6, horizontally it is this side to the right, which is positive. Vertically is downwards, which is negative. That's why you see positive horizontal and negative vertical. Then for 2.83, horizontally is to the right, which is positive. Vertically it is upward, which is positive. So all will be positive. For 4 newtons, horizontally it is to the left, which is negative. Vertically it is downward, which is negative. So negative horizontal, negative vertical. Now when I add the upper components, I'll come up with 5.1973. Add the lower components, I'll come up with negative 4.4630. So now I'll have to draw my right angle triangle to be able to get the magnitude and direction. So positive horizontal is to the right, and negative vertical is downward. Then the resultant is a line joining from start to end. So by Pythagoras theory, I can get the magnitude, and also by SOHCAHTOA, I can get the angle. And then I'll state or conclude the magnitude and direction. So the same procedure will be used for all these questions, but I shall do a number of them for it to be conversant with the topic. So question 3 came from U.A.C.E 1992, paper 1, question 1b, and it says, 3 forces, these ones act at a point as shown in the figure above. Find the resultant force. So still we shall follow the same procedure. Resolving, so resolving 3.5, positive, positive. That's why all are positive. Then 1.7 is entirely vertical, so it will be 0 horizontally and 1.7 vertically. Then this one, it is negative, positive. That's why there's negative here and positive here. When you add, you come up with that. Then we can now come and draw our right-angled triangle. Positive horizontal is to the left, is to the right, and positive vertical is upward. Then the resultant is the line joining from start to end. So I can use Pythagoras theory to get the magnitude and use SOHCAHTOA to get the angle. Then I can state the magnitude and the direction. Question 4 came from U.A.C.E 2007 paper 1 question 4a and says, a body capital M of mass 6 kilograms is acted on by forces, these ones, as shown in the figure above. Find the acceleration of M. So still we have to first get the resultant. So we shall come and resolve. First thing to do is to get angles to the horizontal. So this was 40, here it will be 50. This was 20, here it will be 70. And this is 60. After getting angles to the horizontal, I can resolve. So let me start with 5. 5 is entirely horizontal. That's why it is 50. 25, it is positive, positive. As you can see them here. 30, it is negative, positive. 20 is negative, negative. After resolving, you add to come up with this. Then from there, you can draw our right-angled triangle. Negative horizontal is to the left, and positive vertical is upward. Then the resultant is the line joining from start to end. Therefore, magnitude can be got by Pythagoras theory. Then the direction from SOHCAHTOA. After that, we shall state. So here they wanted to do acceleration, so we shall remember that F is equal to ma, where F is the resultant force. So I come and substitute for resultant force, the magnitude, and also for the mass, which was given as 6 kilograms. With that, I'll come up with the acceleration as this, and that's what they wanted. So now we shall go to another part called crossing a river. So we have been dealing with the resultant force. Now we are going to deal with resultant velocity. So when one is to cross a river from one point of the bank to a point on the other bank, the effect of current or river flow has to be taken into consideration. And there are 3 ways in which one can cross the river. 1 is crossing the river by the shortest route. Then 2, crossing the river in the quickest time. And 3, crossing the river to a particular point on the other bank. So we shall look at all those 3 cases. Let's start with crossing a river by the shortest route. So when one wishes to cross a river by the shortest route, it implies that he intends to reach to a point on the other bank directly opposite. So this is the key word of by the shortest route. So shortest route means you have to reach a point which is directly opposite the starting point. What does that mean? It means that he should set his boat upstream. Now the word upstream depends on the river flow. If the river flows in this direction and you're standing here, upstream is this side and downstream is this side. On the other hand, if the river is flowing in this direction and you're standing here, then upstream is this side and downstream is this side. So upstream and downstream depend on the river flow. Upstream at an angle theta to the bank, such that the effect of the current enables him to reach that point. The resultant velocity must be in the direction where he intends to reach. So let's try to illustrate that. So those are the two banks of a river, and the width is d, and this will be the direction of current or direction of the river flow. So if I'm at this point and I want to go to this point, then this will be your resultant. So resultant is in the direction where the person intends to go. So he wants to reach exactly opposite where his opposite is starting point. That's why we put resultant velocity there. So that means that he must row his boat upstream at an angle theta to the bank, and this will be the velocity in still water, so that the current or the river flow drives him back to the position where he wants to reach. So that will be the effect of the current will make him reach his destination. So this VC is called velocity of the current or velocity of the river flow, and this one is the velocity speed in still water, speed of the boat in still water, and this will be the resultant velocity. This will be the width of the river, and this will be the inclination to the bank or direction in which the boat is steered. So the good thing, this is a right angle triangle, so you can use SOHCAHTOA. So cos theta will be adjacent over hypotenuse, which gives this. That means that when you know VC and VS, you can get the theta, which will be the cos set. So cos means direction. And also because it's a right angle triangle, you can use Pythagoras theory. So if you know this and you know this, you can easily get the resultant velocity. Then the time taken is distance over speed, but the distance used must be in the direction of the resultant velocity. That is why you see here time taken is d over v, because d is in the direction of the resultant velocity. And with that, you can go through these questions. Question 1 says, a stream is running at 3 kilometers per hour due east. If a man can row a boat in still water at a speed of 5 kilometers per hour, find the direction in which he must row in order to go straight across the stream in northern direction. If the breadth of the river is 100, find how long it takes him to cross. So first we need to make an illustration. So 100 meters in kilometers, it is the same as 0.1 kilometer. So this will be the resultant velocity, and it will steer his boat upstream at a certain angle, and this will be the velocity in still water. Then the velocity of the current. So I've got our right angle triangle. We can use SOHCAHTOA to get the value of theta. Therefore, the boat must be steered at an angle this to the bank. That is the direction. Then here they said if the breadth is 100, find how long they want the distance. So to get the distance, we must first get the speed. Therefore, by Pythagoras theory, I can get the speed as that. Then I can remember that time is distance over speed. So distance is 8b, which is 0.1, and speed is v, which is 4. Therefore, the time will be 0.025 hours. That was question 1. Question 2 says 2 points A and B on the banks of a river are directly opposite. A boy is capable of swimming at one whole number 7/18 meters per second in still water, wishes to swim directly from A to B. Given that the river is flowing at a rate of 5/6 meters per second, determine Roman 1 the boy's speed along a B, and Roman 2 the width of the river if it takes 2 minutes to cross the river. So still we shall need to make an illustration. The width of the river, you do not it. So this will be where the resultant will be. And then we row our boat upstream at this, so that the velocity of the current takes us back to the place where I intend to reach. So good enough, you have got a right angle triangle, so you can easily use it to get the velocity using Pythagoras theory, which gives you that. And Roman 2, they want the width. So a good thing we have time. So width, remember time is distance over speed, therefore distance will be speed times time. So speed is that, time is that. It was minutes, so we have to change to seconds. That's why I multiply by 60 to give you that as the answer. Then crossing a river in the quickest time. So when one wishes to cross the river in the quickest time, the course set will be directly across the river. The current will then carry the boat downstream. So I think you realize the difference. By the shortest distance, you reach exactly at a point exactly opposite your starting point. But in the quickest time, you set your boat in the direction opposite to your starting point, so the current blows you away and you reach at a certain point downstream. So this is the velocity in still water, then the current pushes you away so that you reach at a different point, which is downstream, which is this point B. So this D1 is the distance downstream of the final point where the man reaches. And this D2 is the width of the river. So these are two similar triangles. I can use velocities, this and this. Or I can use distances, still they all will give the same ratio. Therefore, direction can be got from either this or this, depending on what is given. Then the resultant force can be got by Pythagoras theory, and the distance by Pythagoras theory also. And the quickest time will be d over v. Now that d is the distance from here up to here. Because we said the time got, the distance used must be in the direction of the resultant force. So that we are going to this question. It says a boat can travel at 6 kilometers per hour in still water. A river is 250 meters wide, and the current flows at 4 kilometers per hour. Calculate the shortest time taken to cross the river and the distance downstream that the boat is carried. So to cross the river in the shortest time, the course set is directly opposite the river. So this is the width which was given here. Therefore, this will be the direction of the velocity in still water. Then the river current pushes you away so that you reach a point which is which is downstream. So the question said they want you to get the time and also the distance downstream. So the distance downstream is this d. So by similarity, we shall come up with this. This is now distance and this is velocity. So distance will be given by that. From Pythagoras theory, we shall come up with the velocity as that. Then also Pythagoras theory, AB will be given by this Pythagoras theory, so that we can easily get the quickest time because we know AB and we also know V, and that will be the time they wanted. What about crossing to a particular point on the other bank? So in order to cross the river and reach a point B on the other bank upstream, the course set must be in such a direction that the resultant force, the resultant velocity of the boat is in the direction AB. So let's try to illustrate that. So this is where I intend to reach, and that's where my resultant velocity will be. Therefore, I must set the boat upstream so that the wind takes me back to the original point where I intend to reach. So I'll come and put my velocity in still water at that point. Then the velocity of current will push me to the original place where I intend to go. So I can get the value of alpha. If I know this and I know this, I can get the value of alpha. After getting the value of alpha, I can easily get the value of theta 3 because they all add up to 180. Then by sine rule, sine theta 2 over Vc is equal to sine theta 3 over Vs. From there I can get the value of theta 2, and after getting theta 2 I can get this, which will be the course set or the direction in which the boat will be steered. Then also using cosine rule, I can get the resultant velocity because now it's no longer a right angle triangle. Then I can get the distance AB from Pythagoras theory, and after that I'll get the time taken to cross the river. So that shall go through this question. Question 1 came from UNEB 2003, paper 1, question 1C, and says a boat crosses a river 3 kilometers wide, flowing at 4 meters per second to reach a point on the opposite bank 5 kilometers upstream. The boat's speed in still water is 12 meters per second. Find the direction in which the boat must be headed. So let this be the direction in which the boat is headed. So you come and draw the two banks. This is the width. So this is where the resultant velocity will be. They said you want to reach a point 5 kilometers upstream, and the width is 3 kilometers. So the velocity in still water will be in the direction, then the velocity of current will push you back to the original place where you intend to reach. So I'll still go through the same procedure. Using this rectangle triangle, I can get the value of alpha using the distances. Then this alpha plus this add up to 180, so theta 3 can be good. Then by sine rule, theta 2 can be good, implying that theta 1 is alpha minus theta 2, which gives you 21.09. And that's what they wanted. So what we have been covering has been resultant velocity. Now we shall go to what we call relative velocity. So relative velocity is the velocity of a particle as perceived by a moving observer. So let's consider two vessels A and B which are in motion where each is moving in a specified direction. So the velocity with which A appears, this word appears, means it's not the actual velocity but just appears. So the velocity with which A appears to move as observed by an observer in vessel B will be different from its actual velocity, and this is referred to as the relative velocity of A to B. This means that if VA is the actual velocity vector of A and VB is the actual velocity vector of B, then the relative velocity of A to B will be denoted by VAB, and it's defined as VAB equal to VA minus VB. So what you should note, there are two things you should note. One is that what is here is the first followed by this. Then two, you should note that these are vectors. I think you see this tilde symbol. So these are vectors. They are not only magnitudes. It is a vector. So for you to use this formula, you must make sure that VA is a vector and VB is a vector. And these two are not the same. They are not the same. VAB is VA minus VB, while VBA is VB minus VA. So they are not the same. And with that, we shall go through this question. So now we know how to convert magnitude and direction into vector. 2, we know how to get magnitude and direction of a vector. And 3, we know how to resolve. So all those will be combined to be able to come up with the solution to such questions. So question 1 says a cruiser is moving at 30 meters per second in the direction this. So we are given magnitude and direction. Therefore we have to first convert to vector. And a battleship is moving at 20 meters per second in a direction 20 north, 20 degrees west. What is the velocity of the cruiser relative to the battleship? So the order matters. Cruiser first, followed by battleship. So the first thing to do is to make an illustration of what is given so that we can get the magnitude direction. So this is 30 meters per second, and it is north 60 degrees east. But remember we said for you to resolve, you need to get an angle to the horizontal. That's why you get this 30. That is for the cruiser. Then for the battleship, it is 20 meters per second in the direction north 20 degrees west, which is this. But our interest is the angle to the horizontal. That's why I get this 70. Then now we can resolve. Always the upper part has cos, lower part has sine. So positive horizontal, positive vertical, which is that. Negative horizontal, positive vertical, which is here. After resolving, you can now use the formula because they are now in vector form. So VC, C is the cruiser, B is the battleship, is equal to VC minus VB. So substitute for VC and for VB and give you answer to 4 decimal places. So after that, we have to get the magnitude and direction. So positive horizontal is to the right, negative vertical is downward. The line joining start to end is the result, is the relative velocity they want. So that means we can use SOHCAHTOA and also Pythagoras theory to get magnitude and direction. So Pythagoras theory gives you the magnitude as that, then SOHCAHTOA gives you the angle as that. Therefore, we can set the direction that south 83.41 degrees east. How does it come about? So this is the angle which you have got theta. So this is south and this is east, meaning it will be south 30 degrees east. And that's what they wanted. Then question 2 says to a motorcyclist, not this word to a motorcyclist traveling due north at 50 kilometers per hour, the wind appears to come from northwest at 60 kilometers per hour. So appears meaning this one is not the actual velocity of the wind. It is just the relative velocity. So the velocity of the wind relative to the motorcyclist. That's what it means. Find the true velocity of the wind. So you first make our sketches to easily convert to vector form. So this is north. Okay. Then this one is northeast. Sorry, northwest, which is there. So with that I can now convert to vector form. V of the motorcyclist is that because it is entirely vertical. The relative velocity, it is negative horizontal, positive vertical, which is here. Therefore I can get first got the formula for relative velocity, but I want to make VW the subject. So take this one this side to come up with VW equal to this plus Vm. So substitute for relative velocity and for Vm to come up with these two for decimal places. Then I come and draw my right angle triangle. So positive horizontal and positive vertical. Then the line from start to end is our true velocity. So I can use Sokatoa and Pythagoras theory. Pythagoras theory gives that as the magnitude, then Sokatoa gives this as the angle, therefore direction will be that. And that's what they wanted. Question 3 says to, still starts with the word to a person in a ship A moving due east at 15 kilometers per hour, ship B appears to be moving at 12 kilometers per hour in the direction north 30 degrees east. Find the true velocity of the ship. So we shall make a sketch. This is for that due east. Then for this one is north 30 degrees east. So from there you can now get the vectors. This one is entirely horizontal. This one we shall come up with that positive horizontal, positive vertical. So I'll come and code the formula for relative velocity, but I want to make B the subject, so it will give me relative velocity plus VA. This is relative velocity and this is VA to come up with this as the vector of VB. So I can come and draw my right angle triangle. There is positive horizontal and also positive vertical. Then from start to end will be VB. So it's a right angle triangle. I can use Sokatoa and Pythagoras theory to get direction and magnitude. So for magnitude, that will be the magnitude, and for direction, that will be the angle. Therefore, direction will be north 63.67 degrees east. Question 4 says, to a pilot on a plane flying at 180 kilometers per hour on a bearing of south 30 degrees west, the wind appears to blow from now here they're using the word from south 40 degrees west at 190 kilometers per hour. Find the true speed and direction of the wind. So for this first one, it is south 30 degrees west. The second one is from south 40 degrees west. Now here I think we realize this one will just due and this is from. So the arrows differ. From means the arrow points towards the center of the compass. and this one, the arrow is away from the center of the compass. So now we shall convert to vector form. This one, it is negative horizontal, negative vertical. Then for this one, it is positive horizontal, positive vertical. So I know that VW is VWP plus VP. So come and substitute for this and for this to come up with this. Then I'll draw my right angle triangle. So I think we realize the procedure is the same for all questions. So positive horizontal, negative vertical, then the velocity of wind. So from there, still you do the same Pythagoras theory and SOHCAHTOA. So magnitude will be that, and angle will be that, therefore direction is that. And that's what they wanted. So now that has been relative velocity, now shall go to what we call closest approach. So consider two bodies A and B moving with velocities VA and VB respectively. If body B is initially at a distance d due east of body A, the time t when the bodies are nearest or closest to each other and the shortest distance between them can be got as follows. So the first step is to draw a line joining the initial positions of A and B. Remember, they told us that initially, body B is initially a distance this due east of A. So I shall come and draw. A will be here and B will be due east. And the distance is d apart. So that is step 1, a line joining the two initial positions. Then step 2, for relative velocity of A to B, the relative path is drawn through body A. So note this, body A, because A is the starting part, and a perpendicular line is dropped from point B to meet the relative path at C. So shall come at body A and draw the relative path. Relative path is this, the relative velocity, direction of the relative velocity. And then at body B, drop a perpendicular to meet the relative path at point C. So in that case, the distance BC is what we call the minimum distance or the shortest distance between the two bodies. So step 3, the shortest distance BC between the two bodies after time t is given by this, because this is now a right angle triangle. If you look here, this one is a right angle triangle, meaning using this I can say sin theta is equal to d mean of BC over AB, which is that. Then step 4, they can also ask for the time taken for closest approach, and that will be given by the formula that time taken is equal to distance traveled along the relative path over relative velocity. So the distance will now be SC over velocity of A relative to B. So let's go back to the diagram and we see. So remember, this is the relative path. So the distance traveled along the relative path will be from A up to point C. So distance SC divided by this relative velocity will give you the time taken for closest approach. So usually they ask for relative velocity, shortest distance, and the time taken for closest approach. So with that, shall go through these questions. Question 1 came from UNEB of 2008, paper 1, question 1b, and it says, Roman 1, a ship A is traveling due north at 20 kilometers per hour, and a ship B is traveling due east at 15 kilometers per hour. Find the velocity of A relative to B. That is Roman 1. Roman 2. If the ship B in Roman 2, so that is now Roman 1, because here it was Roman 2 and Roman 3, so it will be Roman 1, is 10 kilometers due west of A at noon. Find their shortest distance apart and when this occurs. So shall need to draw our diagrams to convert the magnitude to vector form. So this is VA due north. We also have VB, which is due east. So in vector form, VA will be entirely vertical, so it will be 0, 20. And VB is entirely horizontal, so it will be 15, 0. Therefore, VA relative to B, which is this, will be VA minus VB, VA, VB, to give you negative 15, 20. So shall draw a rectangle triangle, negative horizontal and positive vertical. Then from start to end gives you the relative velocity. So by Pythagoras theory, we can be able to get the value of theta. So magnitude is that, Pythagoras theory, then SOHCAHTOA, we get the value of theta. Therefore the direction is north, 36.87 degrees west. That is Roman 1. Then Roman 2. Roman 2, they said if ship B is 10 kilometers due west of A at noon, find their shortest distance apart and when this occurs. So we shall go through the steps. One is draw a line joining the initial positions of A and B. So they said B is west of A, that is why we put A here. Then the west of A is where B is located, and the distance apart is 10 kilometers. Then from there, they want A relative to B, meaning that you are going to draw a relative path from A. And remember the direction of A was north, 36.87 degrees west. So from north towards west is 36.87. Meaning the balance would be 53.13. That is our relative path. Then at B, we shall drop a perpendicular to meet the relative path at point C. Therefore, distance BC is now our shortest distance. Therefore, shortest distance is BC, which is 10 sine 53.13 degrees, which gives you 8 kilometers. So remember, this is a right angle triangle, so sine this is equal to opposite over hypotenuse. That is how this comes about. Then for the time, remember time we use the distance along the relative path. So we shall use distance SC, which is 10 cos 53.13 degrees over the relative velocity, which is 25 kilometers per hour, to give you this hours. Then question 2 says a ship A moves due north at 30 meters per second, and another ship B moves north 60 degrees west at 20 meters per second. Roman 1. Find the velocity of B relative to A and the direction. Then Roman 2. If B is 10 meters due east of A at this instant, find the closest distance of approach of the two ships. So the first thing to do is to draw the sketches so that you can easily get the vector form. So this one is north, then this one is north, 60 degrees west. So in vector form, this is entirely vertical, so it is 0, 30. This one is negative horizontal, positive vertical, which is this. Therefore, VB relative to A is VB minus VA. VB, VA to give you this. Then you can draw our right angle triangle. It is negative horizontal and negative vertical. So from start to end is the relative velocity. So now you can get the magnitude and also the direction. That's the magnitude, then the angle is that. Therefore, the direction will be south 40.89 degrees west. Then for Roman 2, we shall first join the initial positions of A and B at that instant. They are 10 meters apart, so draw a line because it is now B relative to A. So at B is where you draw the relative path. Then from A, you drop a perpendicular. After getting the right angle triangle, you can now get the minimum shortest distance, which is that. So they only ask for shortest distance, but in case they ask for shortest time also, or the time taken, it will be now BC over relative velocity to give you this. So now we shall go to question 3. It says a ship P moving with a velocity of 40 kilometers per hour due east, while ship Q is moving with a velocity of 30 kilometers per hour due north. Given that Q is initially 200 kilometers due east of P at noon, find the time when the ships are nearest each other and the shortest distance between them. So still we shall first draw diagrams to easily convert from magnitude to vector form. That is ship P entirely horizontal, then Q is also entirely vertical. So in vector form, we shall come and get P, which is entirely horizontal, and Q, which is entirely vertical. Therefore, the relative velocity will be Vp minus Vq to give you this. Then we shall draw our right angle triangle with positive horizontal and negative vertical. Then from start to end is the relative velocity. So from there you can get the magnitude and also the angle. So magnitude will be that, angle will be that, therefore now we can now get the shortest distance by showing the initial positions of P and Q and the distance apart. Now here we have P relative to Q, meaning we shall come at P and draw the relative velocity. Then at Q, we shall drop a perpendicular to meet the relative velocity. So now that you have got a right angle triangle, you can easily get the D minimum, which is QR, to give you 200 sine 36.87, which is this, and that will be the shortest distance. Then shortest time, it is PR over this relative velocity to give you this. In hours, then you convert to minutes, so it will be 3 hours and 12 minutes. But remember, I started at noon, so at noon you add on 3 hours and 12 minutes to give you 1512, which is now 12 minutes past 3 p.m. And the distance is that. Then question 4, ship A steers northwest at 60 kilometers per hour. Whereas ship B steers southwest at 50 kilometers per hour. Initially, ship B was 80 kilometers due north of A. Find Roman 1, the velocity of A relative to B, and Roman 2, the time taken for the shortest distance to be reached, and C, the shortest distance between A and B. So still we shall first make a sketch to convert to vector form. So this is ship A, northwest, then ship B, which is southwest. So shape A, it is negative horizontal, positive vertical, which is that. Then shape B, it is negative horizontal, negative vertical. Now the relative velocity is VA minus VB, and that will give you this. So now we shall come and draw our right angle triangle with the negative horizontal and the positive vertical. So we have negative horizontal and positive vertical. Then from start to end will be our relative velocity. Therefore the magnitude will be given by that, and the value of theta will be that. Therefore the direction is north, 5.19 degrees west. So here they also wanted the shortest distance and the time taken. Therefore we shall first locate the initial positions of B and A, which are 80 kilometers apart. Then we have VA relative to B, meaning that at A we shall draw our relative path. Then from B we shall drop a perpendicular. So I got a right angle triangle, meaning you can now get the time, which is AC over VAB, to give you this, and the distance, which is 80 sine 5.19, to give you that. And that's what they wanted. So that brings us to the end of this video. Thanks for watching, and be reminded that next video will be on projectile motion. So if you have not yet subscribed, please click on the subscribe button below this video, such that you can receive updates when the next video has been uploaded. And also, if you know of any student who is not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp, so you can all benefit as a family.